This video presents the work inside the San Martino-Genoa tunnel. This tunnel is along the railway track that goes from Genoa to La Spezia, specifically between the Brignoli and Sturla stations and near the Genoa-Brignoli train station. San Martino is a twin-bore tunnel whose traffic goes west to east, and the work takes place on the left-hand side of the tunnel. The construction site is in the area near Via Giovanni Torti and towards Brignoli, the railway station by the entrance to the tunnel. In the construction site, there are both materials and vehicles to be used for construction, and among these, prefabricated concrete to be used to build the drainage channels. The problem with the tunnel odd track is the platform level, since the high water flow stagnates because of the lack of drainage. As you can see, the water has created an unacceptable situation because of the water infiltration in the rocks, forming mud flats and making the platform insecure when the trains pass. While preparing the site, the entire tunnel was surveyed, and during the months of May and June, night work was carried out, involving pinning pillars with the help of the construction train in order to avoid structural failure during the milling operations. Over both sides of the tunnel, wooden boards have been placed at a height of 70 centimeters as a reference value for the tunnel elevation track. During the first stage, using an excavator, the railway ballast is removed to allow the flattening of the section. Here one can see the milling machine operating a reduction of the surface, with a first treatment of about 25 to 30 centimeters in thickness. The outcome of the operation of the milling is in the result itself. One can see how the materials are loaded onto the trucks, which will transport them to a specific area dedicated outside the tunnel. Here, the materials will temporarily sit, waiting to be analysed to determine their disposal according to law and regulations. The following sequences show the operations of the milling machine and of the excavator that are repeated until they can reach 2.24 meters in depth in reference to quote zero, that is, the measure previously fixed in correspondence to the wooden boards set by the pillar located along the entire length of the site. For a more precise operation and to avoid mistakes, the milling machine is connected to a laser sensor system inside the tunnel that allows obtaining the required slope, keeping the milling machine drum at the necessary level. Once the surface of the tunnel has been leveled down to 2.24 meters depth, as shown, the fibre-reinforced concrete foundation is poured, with regular sloping for the first 650 meters of the tunnel. Then, the next sloping of the canal is of 3.42 meters over a kilometer. purpose of the concrete slabs with regular sloping is to create a supporting surface to lay the prefabricated kits called drain canals. The drain canals are 2.70 meters wide and 67 centimeters high, including the tops that have been designed to support the weight of the trains. Now you see the loading and laying operations of these canals that collect the water and direct it to the outlet, paying attention to the positioning and closing of the canals. At the end of the laying operations, the prefabricated kits are covered with a geotextile fabric to protect the drain canals from deposits of thin soil dissolved into the water over time. At the top part of the drain canals, where there's a minor leak of water, a corrugated conduit is laid down to drain the water, so that it's easily collected in the middle section to facilitate channeling into the drain canals. Here one can see corrugated conduits used for drainage, and the operations to position them in the next 300 meters, beside the 650-meter drain canals. Finally, the timbering and ballast are restored along the entire tunnel.